Now in this video, I'll be showing us how we can find the resultant for two vectors that are perpendicular to each other. Now, we have considered different cases. Now we want to look at perpendicular vector. This is a case under inclined vectors. When two vectors are perpendicular to each other, a fact that we need to know is that the angle between them is equal to 90 degrees. Now, how do we see that? Let's see that in a diagram. Let's say this is a box, and the box is being pushed by a man in this direction with force F1, and then another man pushes to this direction with force F2. Let's call it F2. F2. Now, if we extend this line of force and this line of force, both of them will meet at a particular point. This point where they meet is the point of action, where the force actually acts from. So we now see that there is 90 degrees between them. So this is perpendicularity sign. There is 90 degrees between them. Now, what do we do in this case? Let me redraw the diagram and let me remove the box and just use the diagram like that. I want to remove the box. So let's draw the inclination angle very well. So this is the point of action. Now, according to parallelogram's law of vector addition, parallelogram's law is saying that if two vectors are represented in magnitude and direction by the two adjacent sides of a parallelogram, so there is angle of inclination here, then the resultant is represented in magnitude and direction by the diagonal of the parallelogram drawn from the point of action. Now I can complete this parallelogram. Let me produce a line of force from here to here, parallel to F1. Now this is F1, here too will be F1, because they are of the same length and they are going in the same direction. Then I can compute, let me produce another line of force parallel to F2. This and this are also parallel to each other. You can call this F2. Now, this is a complete parallelogram. And this kind of parallelogram is rectangle. This is a rectangle. Now we can draw our resultant. This is the point of action. Resultant can come from here or from here. But according to the law, it must come from the point of action. We cannot draw the diagonal from here. Let's draw the diagonal from here. So then our R will be here. If this is 90, we have 90 here too, we have 90 here, we have 90 here. Now this is perpendicularity sign. If you look at this diagram, this is a right angle triangle. And in a right angle triangle, to get the hypotenuse, which is the resultant, you can just use Pythagoras theorem. So let me put F1 here also. You can just use Pythagoras theorem. That means R squared will be equal to F1 squared plus F2 squared. So solving this diagram, solving this formula, so using this formula we'll get our resultant. This is the formula for finding resultant in opposite diagram. And later you take the square root of both sides, you get your resultant. Now to find the direction of the resultant. So the direction will be the angle between the resultant and the north pole. So that is, this is north and this is east. So we know north and south are reference points under compass bearing. As if we are using compass bearing, and most of the time we use compass bearing. Now, to under compass bearing, we either come from north to wherever our line is. We move from north to wherever the line is. So, if the vector diagram is downward, so we move from south. North and south are reference points under compass bearing. But under 3-digit bearing, so we must always come from the north to wherever our line is. So I'll be explaining this in subsequent video. But right now, in this case, we will come from the north to wherever our line is. Let's put theta here. So if we find the tan of theta, the tangent of theta, that will be opposite all over adjacent. Our opposite is F1 and our adjacent is F2. That means tan theta is equal to opposite, which is F1 all over F2. Definitely, if we take the arctan of both sides, theta will be equal to arctan of F1 all over F2. So, to completely state this resultant, I will say that my resultant is equal to R resultant equal to R Newton in the direction north theta degree east. So when we start applying formula, we are going to see what is happening here. Thank you for viewing this. God bless you.